Hi, I'm Rachel. She's Oraya. We are DPhil students within the ground project. We started in April this year. So I'll just do a bit of the background and objectives, then Oraya will talk about our methods and our preliminary assessment. So AMR led to the death of 1.27 and 1.1 billion people in 2019 and 2021 respectively. And the burden is mostly seen within sub-Saharan Africa. So we'll be working to estimate the prevalence and burden of MR. I'll be focusing on E. coli, looking at the human, environmental, and animal estimates, while Oraya will be focusing on Acinetobacter baumannii. So we'll develop and apply methods that to better understand spatio-temporal dynamics of AMR. So our estimates will be by age and sex, and then we'll try to look at the specific geographic hotspots of AMR, compare hospital-acquired infections and the community-acquired infections, so the risk-type infections. And then also develop methods to try and address or adjust or modeling of the diagnostic bias. We will also try and look at the drivers of AMR in these specific bacterial species.
Yeah, so this is just a very general overview of our methods so far. Since we did start a few months ago, this is still changing quite a bit. But so far, we've done an initial literature review just to review some of the methods that are currently being used to estimate the prevalence of AMR. And this is mainly through the GRAM 1 and GRAM 2 studies. We want to understand our pathogen also on a more specific way, so we can try to identify characteristics that we can also include in the model. And then we want to aggregate data, so specific to our pathogen and covariate data that we can use. So for example, with E. coli, Rachel is taking a look at more data on a community level, and then for Acinetobacter baumannii, I'll be taking a look at more hospital data that I can use in my model. Taking that data, we want to use it to build our model. So this would be more pathogen specific. We can consider a community-based approach and then a hospital-based approach, and then combine them. And then taking that, then we want to validate our models. We're still in the process of the model development and then the model validation stage. So this will go hand in hand. This will be an iterative process. So these are some of the results we have so far. So this is just an example of some of the covariate data that we have. So this is lack of access to hand washing facilities at the community level. We've also collected a few hospital-based covariates. And so far, this is for Acinetobacter baumannii. We've built about 8 models. This is one example of fitting a logistic growth curve, which is the solution to an SIS model. So with STAN, we're trying to estimate 3 parameters, which is the initial resistance, inflection point, and then the carrying capacity. And then we're considering the random effects at the country level and then using a binomial likelihood distribution. We've also tried approaches using INLA brew, other methods in STAN, also very basic optim using least squared error methods. And then next, we're going to try to incorporate some of the covariates that we have, so specifically for the community, and then combine them also with the hospital setting.